Okay, so everybody thinks electrical engineering is really hard, but in fact, if you have the right teacher, it's really, really simple, okay? So in this video, we're going to be building a 3-phase full bridge inverter, which is going to convert DC power to 3-phase AC power to run things like induction motors, which is the most important one. And this video is going to show you how. So if you're a hobbyist, if you're a student, if you're just interested to learn about inverters, you're in the right place. So stay tuned and ask as many questions as you want. Okay, so let's dive into what the inverter looks like. And it's a simple circuit. Okay, we have 6 transistors, and we have, these would be, the 3 loads are going to be like your coils in your motor. And then we have a battery. Okay, so how do we get negative and positive voltages from this circuit? Okay, so let me show you. So first thing we have to go over is these 3 sections. These are called legs, okay? And it's very important to know that when S1 is closed, S4 has to be open, okay? If both of them are closed, or if both switches on the leg are closed, it's going to create a short circuit. That is not what you want. If you create a short circuit, you're going to blow your whole circuit, okay? We don't want that. That's bad, okay? So you have to realize the fundamental rule is that the switches have to be complementary of each other, okay? So let's run through a scenario. Let's say we have switch 1 and switch 5 closed. So they're going to be closed, which means S2 and S4 is going to be open, and it means S6 is going to be closed, okay? Let me just thicken up this for a second. Let's go through how the current's going to flow. So through S1, we have it coming up, down, through load A, right? And it's going to come to this neutral point right here. Same thing with, I want to use a different color here. For S5, it's going to come down, right? It's going to go through load C, and we're going to meet at the neutral point. Now what's going to happen is it's going to go through phase B, right? And I'll use a different color again. And if you can realize, that voltage that's going through phase B is going to be negative, okay? And that's 1/2. Now, in this video, we're not going to go over sinusoidal. That will be in another video, and we're going to use PWM for that. This video is just purely focusing on the mechanics, just the base principle of a 3-phase inverter. So for learning's sake, we're going to use square waves to teach this. Now that we have identified how to get positive and negative on each of our phases, I have 3 graphs here that we are going to generate our 3-phase inverter. So we have 3 phases that we need to generate, and each have to be 120 degrees out of phase with each other. And if you notice here, I have a table of the timing of each of the switches. This is going to be broken up into 6 time segments, okay? So we're going to focus on 1 full cycle. So we're going to make phase A first. So to make phase A, we're going to go positive voltage all the way to 180, and then go negative all the way to 360, because that is 1 full period, okay? Phase B, we're going to, let me just do that. Phase B, we're gonna shift it 120, okay? So I have the degrees right here. So we got 60, 120, 180, and so forth all the way 360. Okay, so let's shift the first sine wave over 120, and that is going to look like something like this. Okay, we'll go over 3, down, across, and that's what that's going to look like. Okay, and that's phase B. That is shifted 120. Phase C, we're going to do the same thing, and phase C is going to look something like this. And across. All right, and that's gonna look something like that. So then you have these square waves that are precisely 120 degrees out of phase. All right. Now, if we look at the first time slot, we're going to see, right, at 60 degrees, use a different color here, 60 degrees, look at all of the voltages. Notice all the voltages, right? We have A, positive, B, negative, and C. So we have A, which is positive, we have B, which is negative, and we have C, which is positive at time 0, okay? So that's great. Let's put that here over on our inverter. Let's do that in green. That's gonna mean if we follow the table, all right, I'm gonna show you here, S1's closed, so we're gonna close S1. We're gonna open, S4 is always gonna be complementary, S3 is gonna be open, all right? S6 is gonna be complementary, and S5 is gonna be closed. All right, now watch what happens. S1, so the current's gonna flow through S1, that's gonna be positive, all right? Current's gonna flow through S5 as well, and that's also gonna be positive. They're gonna meet at the neutral point like we've discussed, go up, that now phase B is negative, and it's gonna return to ground, all right? Now, if you follow that table down the whole way, you will find, you can work through it by yourself, you will find that you will be able to get 3 sine wave or 3 square waves that are perfectly 120 degrees out of phase. And in the next video, I'm going to show you how I build this circuit in Tinkercad and show you how the LED, and I'll display the loads through LEDs and show you how we can get these 3 phase to work in real life. And then in the next one, we'll actually build the circuit. And so stay tuned because we're going to do all that. All right.